Again, here's my weight in cars, my weight in trucks, my total weight. I'm going to choose, if I know trucks, I need to find cars. I'm going to choose to isolate cars first. And this makes sense in context. So check it out. If I take all my weight and I take away the trucks, what am I left with? The weight of the cars. But I want to know how many cars. So I'm going to divide everything by 3.6. And so here's why this is more efficient. What can I just put in right here over and over? What can I just put in right there over and over now? The number of trucks. So I'm going to put 480 in for T. So someone help me out on your calculator. 21,600 minus 7.5 times 480. And then we're going to divide that by 3.6. I think we get 500 cars. 5,000? Oh man, I'm off by 0.
We came up with a different equation. I don't know if it's wrong.
Here, I'll calculate it.
Mr. Matt.
Okay, so it is 5,000 cars. See, you can just recycle that, thanks. So this time, what am I going to put in here over here for T? For B? What am I going to put in there now? 1,500. That's the number. So 21,600 minus 7.5 for each of the 1,500 trucks. That means I have 10,350 tons I can put on there. We'll divide that by the cars, 3.6, and I got 2,875 cars. Now, we're going to load it up with trucks, huh? 21,600 minus 7.5 times the 2,736 trucks. And that means I have 1,080 tons left. Divide by 3.6 per car. 300 cars. So a lot of people were plugging in and then solving, plugging in, solving, plugging in, solving. Does that work?
Yeah.
Okay. Is it as efficient? No. So it still gets you there. So I'm promoting solve once, plug in and go. Okay? How do I know that, again, big idea, how do I know that my new equation is equivalent to my original? I did the same thing to each side to get equivalent equations over and over to make my new one. So you're going to try doing this again. Don't worry about this junk down here. We don't need the calculator thing. So you're going to give me equation for cars. I'm going to tighten this up right here. So you're going to know how many cars are going on there. The cars are going on first. I want to know how many trucks can go on then. Checking this one out, I have the same original equation, but this time I'm loading cars first. So what's left over? Trucks. So I'm looking to get T equals. So I'm going to subtract the total weight of cars from both sides. So I'm left with trucks. I'm going to divide by the weight of a truck to see how many trucks I can get on there. And the number of trucks I can get on there is total weight minus the weight of cars divided by 7.5 per truck. So where am I going to throw this 1,000? That's the number of cars that are getting loaded on first. And now it's just a calculator issue, okay? So we're going to take our 21,600. We're going to take away 3.6 per 1,000 cars. That leaves 18,000 pounds for trucks at 7.5 tons each. We can fit 2,400 trucks. All right. Now we got to do another one. 4,250. Put it in for here. And here's the cool thing. Depending on your calculator, you don't have to retype that in. You can go up to what you already typed and just change that one number. So I got 6,300 for trucks divided by 7.5 per truck. I can do 840 trucks in this case.
Wait, how's the first one 240, but then the second one is 840? No, 2,400.
It's 2,400.
Oh,
2,400. I think it's because I said 100. I said 2,400 instead of 2,400. That might have got you. So again, why do I need the two equations? Well, if trucks get loaded first, I need to know how many cars go on. If cars get loaded first, I need to know how many trucks go on. Is this original equation very nice for either one of those things independently? Not really, because you have to substitute in, subtract, and divide over and over and over. where if you just took the time to make these two equations, you plug it in, get an answer. Plug it in, get an answer. So this is how spreadsheets work a lot of times too. Plug it in, get an answer. Our next situation is very exciting things. Making some new roads. So to pave a mile of road, it costs $84,000 in this town. And they need people to do this. And those new people they hire are $36,000 a year. The budget for a year is about $1.9 million. Okay? So a mile is this much money. A worker is this much money. And we've got this much money. Your job is to make an equation, solve for P and solve for M. P is the number of people. M is for the number of miles. Okay. So here is my original equation I'm working with. I've got 84,000 per mile plus 36,000 per person working to total $1.9 million. So if I want to know, depending on mileage I need to pay, how many people I can hire, here's what I got to do. I'm going to get M alone by subtracting 36,000 P. Okay, which is 1.9 million minus 36,000 P. I'm going to divide both sides by 84,000. And really what this is saying, friends, is if I take all my budget, take away how much I'm spending on people, divided by 84,000, that's the miles I can pave. Okay? Now, if we back that up, this might not be the most efficient way to do this. I probably could have just rewrote my original equation. But now we're in it too deep. If I want to get P alone, I'm going to take away my 84,000 per mile from my budget. I'm left with just people to pay. 1.9 million minus 84,000 per mile. I'm going to divide by 36,000 per person. And that gives me how many people I can hire depending on how many miles I have. Why would I want two different equations?
So we can figure out how many people and miles you can do.
How many people you can use depending on miles, how many miles you can use depending on people, right? Okay. Making roads is expensive is the moral of that story. So, you're going to test these out. The city is going to hire 6 workers. They're going to use their whole budget. So you decide which equation you're going to use. And then you're going to find the number of miles of 2-lane roads you can use if you hire 6 new workers. So which equation are you going to use? And then how many miles can we pave? So, which equation should we use? P equals or M equals?
M equals.
Okay, the number of workers equals, or the miles you can do equals 1,962,800 minus the 6 new workers, which each cost how much? 36 grand? And we're going to divide that by the $84,000 per mile. And then we're going to calculate that. Woo!
20 rows.
I got 20.8 miles of road.
Are we rounding?
Yeah, around the nearest 100 there. All right? So again, this way is easy. We can just plug it in and solve. If we have M equals. Now, in this case, let's look at some miles. We're just going to look at, we're going to do 16 miles. We're going to see how many workers we need. So, people, we have 1.9 million minus the 84,000 per mile, which is 16 miles, divided by the price per person. And then we're going to calculate it up. 1,962,800 minus 84,000 times 16, which means after I pave roads, I have 618,800 left. Divide that by 36,000, and we can hire 17.19 people. So, 17 people.
Well, I like to hire 119.
Well, they just have a little left in their budget, right?
0.19 fill a person eligible.
So if there's that little bit of money left, what should they do with it?
Buy a school.
Pave a little more road, probably, right?
No, pay for library.
All right. So let's check this out. Can we write an equation to describe a situation? Yes. Can we then manipulate that equation if we're looking for one specific part of that equation?
Yes.
Yes. And we want that. It's more efficient, right? We notice it's more efficient than doing the algebra 4 times. You can rearrange your equation once and then just plug in and go, plug in and go, plug in and go. All right, back to your assigned seats, please.